computer can able to understand only the binary languages, that is 0 and 1 only. If it is decimal number, only on that case 1 plus 1 is 2. But if it is binary addition, 1 plus 1 is 0. How to identify whether it's a positive number or a negative number? That can be called as representation of signed integer. Welcome back to one and all. Myself, Vasanta, lecturer in computer science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysore. Today, we will start with the fifth session of data representation. Whereas already in the previous session, you have come to know regarding binary to decimal, how to convert a given binary number to decimal number, octal to decimal number, that means how to convert any octal number to decimal number, as well as hexadecimal to decimal format. With that, you have studied few problems to convert from binary to decimal, octal to decimal, as well as hexadecimal to decimal. Whereas in today's class, you will come to know regarding binary arithmetic, how to add a binary numbers, then binary subtraction, that is how to subtract especially binary numbers, then representation of signed integers, whether it's a positive number or a negative number, how to identify that is sign and magnitude representation, ones complement representation, as well as twos complement representation. Now one by one we'll start. The first one, binary arithmetic. What do you mean by that? Why we require this? We know that the computers perform arithmetic function or operation in binary form only. Computer can able to understand only the binary languages, that is 0 and 1 only. Whatever instructions if I am going to give in English, that is in high level language, that will going to convert into binary format by using compiler. Whereas compiler is a software, it converts the high level language to machine understandable language, because computer can understand only the binary level languages. The binary addition and subtraction are as follows. The addition of two binary numbers is performed in same manner with the following rules. If I want to perform any binary addition operation, then I have to follow some rules and regulations. Whereas in general, 1 plus 1, if it is decimal number, 1 plus 1, we used to write it as 2. But in binary, we don't have 2. They are compulsory way to represent all the numbers by 0 and 1 format only. These are the four major rules you have to follow in binary addition. That is, when you add 0 plus 0, then output represents 0 only. 0 plus 1, when you add, then the value is 1 only. In the same way, 1 plus 0, the value is 1 here. But 1 plus 1, generally in decimal number, we used to write it as 2. Whereas in binary, 1 plus 1, the value is 0 with carry 1. Compulsory to remember. Whereas 0 plus 0, that easily we can able to remember, that is 0 only. 0 plus 1 is 1, as well as 1 plus 0 is 1. But when you come on 1 plus 1, especially 1 plus 1, then the value is 0 here with carry 1. Whereas in binary decimal, 1 plus 1 is 2. Whereas in binary numbers, then 1 plus 1 is 0 here. Then I am going to explain with some problems. Consider we have the binary numbers, that is 100 plus 11. Then what is that binary value? Here in between we have plus operator. Then how to perform this addition? Consider we have the value 100. Then here in the denominator 1 as well as 1 we have. Then here we don't have any value, that's why I will write 0. Then when you add 0 plus 1, the value is 1. Then in the same way, 0 plus 1, the value is 1. And 1 plus 0, the value is 1 here. This is a binary addition format. Already I told you here. Here 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, as well as 1 plus 1 is 0 here. Then consider one more problem here. 1001. I want to perform binary addition. On that case, 1101. When you add 1 plus 1, if you observe here, 1 plus 1, the value is 0 with carry 1. Here also 1 plus 1, the value is 0 and the carry here. For the next neighboring one, you have to give carry 1. Then here 1 plus 0, then the value is 1 here because we get the carry from the neighboring one. Then here 0 plus 1, the value is 1. Once again 1 plus 1. Once again the value is 0 and with carry 1. Then this is the binary addition method. Consider one more problem. Here 10101. Then here 1001. Then already I told you 1 plus 1, the output is 0 with carry 1. Here also 1 plus 1, the value is 0 with carry 1. For the next neighboring one, we have to give carry 1. Then once again 1 plus 0 plus 1. 2 times 1 we have. That's why here once again the value is 0 and with carry 1. Then once again 1 plus 1 plus 0. Here once again I am to get 0 with carry 1. That's why 1. Here once again 1 plus 1 is 0 with carry 1. This is the binary addition method. Like this, you have to perform binary addition. See, here the major rule is 0 plus 0 is 0, 0 plus 1 is 1, as well as 1 plus 0 is 1. But 1 plus 1, it is not 2. If it is decimal number, only on that case 1 plus 1 is 2. But if it is binary addition, 1 plus 1 is 0. Now, I am to explain regarding binary subtraction. In binary addition, this is the major rule you have to follow. But in binary subtraction, 0 minus 0, the value is 0. 1 minus 0, the value is 1. 1 minus 1, the value is 0. But 0 minus 1, 0 minus 1, on that case, the output is 1 with borrow 1. Whereas in binary decimal, especially if it is decimal number, what happens? If I take borrow from the neighboring one, then that borrow represents 10. Whereas here, in binary numbers, if I want to take one borrow, then that represents it is 2 here. That's why here 0 minus 0 is 0, 1 minus 0 is 1, 1 minus 1 is 0, 0 minus 1 is 1 with borrow 1. This you have to remember. These are the major rules in binary subtraction we have to follow. If the lower digit usually it can be called as subtrahend, it is greater than the digit minuend, then borrow 2 from the next column. Whatever value we have from the next column, we take the borrow. That will explain with some problems. Consider we have the numbers 11011 minus 1001. This is the binary number. We want to perform subtraction. In subtraction, already I told you. 0 minus 0 is 0, 1 minus 0 is 1, 1 minus 1 is 0, but 0 minus 1 is 1 with borrow 1. Now, consider the problem. Here 1101, 1, then 1, 0, 0, 1. To make equivalent, here I would write 0 here. Because if you observe here we are totally 5 digits, whereas here 4 digits. To make equivalent, we will write 0 here. Then here 1 minus 1, the value is 0. 1 minus 0, the value is 1. 0 minus 0, 0. 1 minus 1, the value is 0. 1 minus 0 is 1. This is the binary subtraction method. In the question, if you get binary addition, then you have to follow addition process. In the question, if you get binary subtraction, then this is the method you have to follow. Consider one more problem. Here, 101 minus 011. I want to find the subtraction process. Then here, once again, 1 minus 1, the value is 0. Here, 0 minus 1. On that case, we have to take borrow from the neighboring one. We have to take the borrow from the neighboring one. On that case, when I take the borrow, then it represents 2. Then 2 minus 1, here 1, then the output represents 1 here. Already we are given this borrow 1, that's why the output here 0. This is a binary subtraction. Now is it clear? Next, consider one more problem. Consider decimal number, that is 9 minus 6. because in the base we are given as a decimal number 10. Then how to find the binary subtraction? Because we want to find the binary subtraction value. For this sake, first find the binary value for 9 as well as 6. Already I told you. On this case, if I want to convert any decimal number to binary, then division process we have to follow. That is, if I want to find the binary number for 9, 2 4s are 8, remainder 1, 2 2s are 4, remainder is 0, 2 1s are, remainder is 0. The same thing here we have to write. See, 1 0 0 1 for 9. In the same way, for 6 also, see, 2 3s are 6, remainder 0, 2 1s are, remainder 1 here. Now, to make equivalent, see here 1 1 0, but here in the beginning we have 4 digits, whereas here 3 digits. To make equivalent, here we will write 0 here. Then when we subtract, 1 minus 0 is 1, 0 minus 1, 1, 0 minus 1, we will take the borrow from the neighboring 1. Then it represents 2, 2 minus 1 is, then it becomes 0 here. Then finally the result represents 0 0 1 1. Like this, we have to perform binary subtraction. Whereas in subtraction, the rules are 0 minus 0 is 0, 1 minus 0 is 1, 1 minus 1 is 0, as well as 0 minus 1 is 1. Next, we will use the representation of signed integer. Already I told you, computer can able to understand only the binary level languages. Now, sometimes the numbers may be positive or negative, is it no? On that case, how to identify whether it's a positive number or a negative number? That can be called as representation of signed integer. Whether it's a positive or negative, how to represent that? Mainly regarding that it deals. The digital computers handle both positive and negative integers. Usually computers can handle both positive number as well as negative number. So some technique is required for representing the sign of a number, whether it's a positive number or a negative number. This is done by adding another bit to the leftmost bit. We have to add one more extra bit at the left side of the binary number. Leftmost bit of the number is called sign bit. Consider we have 4. For example, 0, 1, 00 represents 4. One more bit at the left side you have to add. This, whether it's a 0 or 1, depending upon that, we will identify whether it's a positive number or it's a negative number. For example, plus 9 is represented as, if you have plus, then here we have to write 0. If it is minus 9, it can be represented as 1, 1, 0, 1. This last digits represent the sign bit. If it is 0, it means that it is a positive number. If the sign bit represents 1, then it represents it's a negative number. There are 3 methods to represent a negative number. The first one is sign and magnitude representation. The second one, 1's complement representation. And the last one is 2's complement representation. In 3 methods, we can able to represent. One by using sign and magnitude, and one more by using 1's complement, and one more by using 2's complement method. Now, one by one we will explain. The first one, sign and magnitude representation. Sign and magnitude representation. See, already I told you, the last bit represents the sign bit. If it is 0, that's a positive number. If the sign bit is 1, then it represents it's a negative number. In this representation, a sign bit is used to indicate whether the binary number is positive or negative. Whether positive or negative, to represent that we are using sign bit. The sign bit represents it's a positive or negative. If the sign bit represents 0, that's a positive number. If the sign bit represents 1, that's a negative number. The most significant bit, MSB stands for most significant bit, is always the sign bit, and the remaining bit stands for the magnitude. If you observe this example, here plus 19, that is plus 0, 1, 9 we are given. Here this 0, 19 value, and here this represents the sign bit. and this remaining values can be called as magnitude. For example, if you have minus 19, then minus represents the sign bit, especially here 1 represents the sign bit and the remaining represent the magnitude of the given number. Now is it clear? Now we'll start with ones complement representation. Already I told you any number can be represented in 3 methods. One by using sign and magnitude representation and one more by using ones complement and the last one is twos complement. Ones complement, what do you mean by this ones complement? Just replace all 0 by 1. Just replace all 0 by 1 and all 1 by 0. That is nothing but ones complement. Just replace wherever they given 0, replace it by 1 and wherever we have 1, just replace by 0. That is nothing but ones complement. This is the simplest method for representing a negative binary number. It just replaces all 0 by 1, all 0 by 1 and all 1 by 0. Wherever we have 1, there just replace it by 0. Consider one example. Here we have 1, 0, 1, 0, 111. Now, just here the 1 is replaced by 0. Here also 1 that is replaced by 0. Here also we have 1 that also replaced by 0. But here 0 that's replaced by 1 and 1 will replace by 0. 1 is by 0. 1 is by 0. That means just replace all 0 by 1 and all 1 by 0. That is nothing but ones complement. Consider one more problem. 0, 1, 1, 1, 0. This is a binary number. How to find ones complement of the given number? Just replace. Here we have 0. Then write down 1. Here 1, 0. Here 0. Here 0. Last one 0. And here we have 1. This is the ones complement of the given number. Just replace all 1 by 0 and all 0 by 1. Consider one more example. Consider we have the number 1, 1, 1, 1, 0, 0. This is a binary number. Then how to find this ones complement of the given number? See 0 here we have 1, 1. Here 0, 0, 0, 0. In the base we have written 2. Like this, just replace all 1 by 0 and all 0 by 1. That represents ones complement. Next one, we have twos complement representation. What do you mean by this twos complement representation? Twos complement representation of a binary number is obtained by taking the complement of the number and adding 1 to the least significant bit position. LSB stands for least significant bit position. To least significant bit position, we have to add 1, then we can able to get the twos complement of the given number. If I want to get twos complement, then compulsory first I have to find the ones complement and then add 1 to the least significant bit position. For example, see here, twos complement of a given number is equals to ones complement plus 1. For least significant bit position, we have to add 1. Then we will get twos complement. For example, consider the binary number 1, 0, 1, 1, 0, 1. Then here, what is the original value here? The original value is 1, 0, 1, 1, 0, 1. Then ones complement of the given number, just replace all 1 by 0 and all 0 by 1. This represents the ones complement. Then add 1 to the least significant bit position. For the last position, add 1. In binary addition, already I told you, 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1. If you have 2 times 1, then here the output is 0 with carry 1. Now here, when you add 0 plus 1, the result is 1, then 1, 0, 0, 1, 0. This is the twos complement of the given number. Whatever number we are given, first we have to find the ones complement of that number, then add 1 to the least significant bit position to get the final result of twos complement. Now is it clear? Next, I am going to tell you, in the exam, you may want to get the question, find or subtract the given number by using ones complement or subtract using ones complement method. If I want to subtract by using ones complement, then I have to follow some rules and regulation. The first rule, find the ones complement of the subtrahend. Compulsory for the subtrahend, we have to find ones complement. What do you mean by subtrahend as well as minuend? The minuend represents the numerator and subtrahend represents the denominator. Whereas here, for the subtrahend, for the denominator value, we have to find the ones complement. Then add this to the minuend. Minuend represents the numerator value. First step, find the ones complement of the denominator value. Then add that number with the minuend. If there is a carry generated, if there is one carry generated, then this carry is called as end around carry. If I get, when I add minuend as well as subtrahend, on that time, if there is a carry generate, then add this end around carry back to the least significant bit position to get the final result. If there is no carry generated, if we get a carry, then we have to add that carry. If there is no carry generated, then recomplement and put negative sign to get the final result. See, first step, find ones complement of the denominator value, that is subtrahend. Then add with the numerator. When I add these two values, if there is extra carry generate, if I get one extra carry, then we have to add that to the least significant bit position to get the final result. If there is no carry, then recomplement and put negative sign to get the final result. Now we'll show with some problems. Consider we have one problem, subtract 12 minus 5 using ones complement. This type of question in the exam you will get for 3 marks as well as for 5 marks. Here 12 minus 5 we have. 12 minus 5 means, what do you mean by that? First step, here 12 minus 5. First step, you have to identify which is the numerator and which is the denominator. Whereas here 12 minus 5 if they are given, then 12 represents the numerator and 5 represents the denominator value. The numerator as well as denominator you have to identify. The denominator can be called as subtrahend and numerator can be called as minuend. Whereas here 12 is the numerator and 5 is the denominator. Find the equivalent binary numbers. Find the equivalent binary number. For 12, the binary number how to find? 2 6 remainder 0. 2 3 here 6 remainder is 0. 2 1 remainder is 1. See, for 12 double 1 double 0. In the same way, for 5 also you have to find the binary number. 2 2 4 remainder 1. 2 1 remainder 0. Then here if you observe for 5 1 0 1, that represents subtrahend. Numerator value is double 1 double 0. This is the numerator value, and here 1 0 1 1 0 1 is the denominator value. To make this one, we have to write extra 0 there. Extra 0 there, and then you have to convert that into ones complement. See, the ones complement, the regular number is 1 double 0 1. To make it as 4-bit, here I will write one more 0. Then when we convert that into ones complement, then 1 0 1 0. The same thing here we written. Denominator value. See the steps. Find ones complement of the denominator. Here we have find the ones complement of the denominator. Then add with the resultant numerator. Then 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 0 with carry 1. If I get extra carry, we have to add that carry to the least significant bit position. Then 1 1 1 0 we are going to get. To get the final result, like this, you have to perform. Now I will show some more problems on the same method. Consider we have subtract 14 from 25 using 1's complement. Then how to perform this? First step, if you observe the previous problem, 12 minus 5 we have. Then 12 represents numerator and 5 represents the denominator. Whereas in this problem, 14 from 25. Then which is the numerator in this question? 14 from 25. It means that numerator represents 25 and denominator represents 14. First step. Then find the binary value for both the numbers. How to find binary value? For 25, the binary value 2 1s are, 2 2s are, here 4, remainder is 1 total. Then 2 6 are 12, remainder is 0. 2 3s are 6, remainder is 0. 2 1s are, remainder is 1. Now for 25, the binary value is 1 1. If you observe here, 1 1 0 then 1. Then in the same way, for 14 also you have to find the binary value. For 14 also you have to find the binary value. Then 2 7s are 14, remainder is 0. 2 3s are 6, remainder is 1. Then 2 1s are, remainder is 1 here. If you observe here, 1 1 0 1. 1, 2, 3, 4, 5 digits we are getting. Whereas here, 1 1 then 0 we are getting. Then we need to make equalize both the sides. That's why here what I will write? First 0, then 1 1. To make equalize, here I will write 0. See the values? Here 1 1 0 we are written. Numerator value, denominator value. Keep the numerator as it is. Don't make any change in the numerator value. That is 1 1 0 1. Convert the denominator value to 1's complement. Convert the denominator values to 1's complement. Then what is the result? Here we have 0. That's why here 1. Then 3 times 1 we have. Then 0, 0, 0. Then 1. First step, find the binary value. Convert the subtrahend value to 1's complement. Then add with minuend. When you add 1 plus 1, what is the value? 1 plus 1 is 0 with carry 1. Then 1, 0, 1. Here 0 with carry 1. If you get extra carry 1, then you have to add that with the result value. Then here 0 plus 1 is 1. Here 1, 0, 1, 0 in the base 2. To get the final result, we have to add that extra carry to the least significant bit position to get the final result. If you observe here, how to identify whatever results you get, is it right or wrong? Just observe 25 minus 14, how much we are getting. Then find the equivalent binary value. Then we can able to identify the result. Now is it clear? Next we'll explain with one more problem. Subtract 35 from 18 using 1's complement. Then how to perform? From this also you can observe 35 from 18. Then with the numerator, on this case the numerator represents 18 and the denominator represents 35. Denominator usually call it as subtrahend, numerator can be called as minuend. Then if you observe here, find their binary value for both the numbers. First I will find the binary value for 18. Then here if you observe, when I want to convert any decimal number to binary, division process we have to follow. Then here it will divide by 9s are 18, remainder is 0. Then 2 4s are 8, remainder is 1 here. Then 2 2s are 4, remainder is 0. 2 1s are, remainder is 0. This is a binary value for 18. In the same way, next find the binary value for 35. For 35 also find the binary value. Then 1s are, 2 1s are, then carry 1, 15. 4s here, 7s are, 14. Remainder is 1 here. 2 12s are, 6. 2 5s are, 10. 12. 8s are, 16. Remainder is 1. 2 4s are, remainder is 0. 2 2s are, remainder is 0. 2 1s are, remainder is 0 here. Okay, now if you observe 1, 2, 3, 4, 5 digits we have, whereas here 1, 2, 3, 4, 5 and then 6 digit we have. Then how to write the binary value for that one? First I will write 1, then 00, then 10 for 80. Now for this one, 1, then next here we have 000, 11, 000, then 11. See here, write down 0 to make equalize. Keep the numerator as it is. Don't make any change in the numerator value. Then 0, 1, 00, 10. Convert the denominator values to 1's complement. That is, here we are getting 0, then 1, 1, 1, 00. Now add these two values. 0 plus 0 is 0. 0 plus 1, 1. 1, 1. Here 1 plus 1. Here it is 0 with carry 1. 1 here. Or you get any extra here? No, we do not get any extra. If you observe the steps, that if there is no carry generate, then what we have to do? We have to recomplement and you have to put negative sign to get the final result. Same way, here what you have to do? We are not get any carry. That's why convert this result to 1's complement and then put negative sign. Here 1, 0, 0, 0, 1, 0 in the base, write down 2. This is the final value, that is, put negative sign to get the final result. Okay. Next class, we will explain how to perform 2's complement subtraction as well as computer codes. What do you mean by computer codes? That is XS3, BCD codes, all the codes regarding that. Next class, we will come to know. Thank you for all of you.